All right, so in this video, I just wanted to talk to you briefly about plate tectonics and how plate tectonics affect the rock cycle. So first of all, plate tectonics, this is a theory that exists about the structure of Earth's crust. And so if we talk about the crust that goes around the entire Earth, the theory is that there are different plates um, that are broken up along that crust. And the plate that we're actually sitting on here in Memphis or Bartlett is the North American plate. And that plate sits on top of, and all other plates sit on top of the mantle. Well, the mantle has convection currents because it's basically magma. It's a superheated rock that becomes liquefied in magma form. Anytime that you have heated liquids, it's going to form convection currents, and convection currents are simply circular motions of that liquid. So you got rising action coming from the core of the Earth up through the mantle, and then it hits the crust, and then it kind of spreads out. And as it cools, it starts to go back towards the bottom where it's hot again. And the Earth's core is very hot, and so it just keeps this. It's almost like putting a plate or some water on the stove, and then it boils up because at the stove surface, that's where it's the hottest, and it boils up and then it cools down when it's at the surface, and it kind of goes back down in circular motion. And that's why if you look at a pot of boiling water, you have spots where there's like bubbles, and you have spots where it's looking like there's the lack of bubbles. And so this convection current drives these plates, and it moves these plates, and sometimes it causes the plates to slide past each other like this. Sometimes it causes the plates to spread apart like this, and magma will kind of fill in those empty spaces, and it creates new rock and new layers. And then sometimes it causes the plates to actually collide. And whenever they collide, and that's where we can have a lot of things happening within the rock cycle. So first of all, there's two different types of plates. One of those plates is the continental plate. The continental plate is kind of what it sounds like. It's the plates that make up the continents. They're land plates, and it's what we walk on, and yeah, that's pretty much it. And then we have oceanic plates that also sound just like their name. These are the plates that are found underneath the oceans. And so you have the body of water on top of these plates, and those plates are much more dense. They're under a ton of pressure, and they exist underneath the oceans. Well, oftentimes these plates will collide. So let's say that we have two colliding plates. One's oceanic and one is continental. Well, continental is less dense and oceanic is more dense. So we're going to say my ringed hand here is the oceanic and here's the continental. And whenever they collide, the oceanic goes down, it subducts, and the continental goes up and it rises. And whenever that occurs, you have the oceanic plates being forced down into the mantle where it melts and it becomes part of the mantle. And it's like a recycling of rock there. Well, the continental crust, it goes up. And at the bottom of that continental crust was some of that mantle that comes up with that continental crust, and it cools as it comes up. It's still in the ground as it cools, but it keeps coming up. Well, at that boundary right there, there's all that magma, and for igneous rock to be created, basically igneous rock to form, whatever rock is creating it first has to melt into magma, and then it cools and crystallizes back into rock, and that's igneous rock whenever it cools. And so at these plate boundaries where oceanic and continental crust meet, that's where you're going to find a lot of igneous rock. And there's some other features that happen as this occurs. So you're going to have mountains that build up. You're going to have volcanoes that occur along these areas. And there's very powerful earthquakes. Because a lot of times when these plates collide, they get stuck and they build up a lot of pressure, and then all of a sudden they explode out. And that releases a lot of pressure in the form of an earthquake. And those are the most powerful earthquakes are at these subduction zones. But sometimes you have two continental plates that collide. And the continental plates, since they are of equal density, one doesn't go underneath the other. They just kind of go up against each other, and they just push up against each other, and a little bit of it goes down, and some of it goes up, and it just forms a mountain, right? And so you have these different type of collisions. Whenever that collision occurs, the magma from underneath where the mantle is isn't released up, so there's not volcanoes whenever there's two continental crusts that meet. At least they're rare. Sometimes they might be able to sneak up through a fissure, but they're not very common. And so these continental plates, they collide, but whenever they collide, it creates a lot of pressure and a lot of heat, because you're talking about trillions of tons of material that are being forced together. And even though it's a very slow forcing together, it still puts a lot of pressure because it doesn't stop. It just keeps moving and moving and moving. And it also forms mountains. And there's minor earthquakes that occur along these plates, but they're not like the major ones at the subduction zones. But along these mountain ranges that form, where there's these lack of volcanoes and where these two continental plates collide, and you know that's two continental plates because you have one landmass on one side and another landmass on the other side, and they collide. And whenever that happens, that heat and pressure turns whatever rock is there into metamorphic rock. So it could be igneous rock, and once it goes underneath that heat and pressure, it causes it to change its crystal structure, and it creates metamorphic rock. If there's sedimentary rock there, then it crushes that sedimentary rock and it puts under all that heat and pressure, and it causes to turn into metamorphic rock. It never melts in this process, it just goes under extreme heat and pressure. And so that's kind of how metamorphic rock is formed. And so um, you have these two areas where you find igneous rock and metamorphic rock. Now, sedimentary rock is actually found where there are not plate boundaries. And so you have mountain ranges that, like in America, in the United States, you have mountain ranges along the west coast, and a lot of those mountains are formed by subduction zones, especially along the coast of California, Washington, and Oregon. There's active volcanoes in those areas. There's earthquakes that occur in those areas, and you have an oceanic crust being pushed underneath a continental crust. And then as you go more towards the interior, you have mountain ranges that are formed by just two continental crusts colliding. The Appalachian Mountains was actually one of those that they collided and they started forming, and eventually those plates just kind of settled into place and they stopped moving. They just kind of got stuck together, and that's where they're going to be. And now they've kind of formed one plate, and they're all moving together now. But where those two continental plates hit, it formed those Appalachian Mountains, and in those ranges you can find a lot of metamorphic rock. But in between those two, you have the Great Plains, and we are in between those two mountain ranges, and where we're at, there's a lot of erosion and sedimentation that come along the way. And so erosion occurs across the Rocky Mountains, and there's winds that pick up all the material along the Rocky Mountains, and it distributes it all across the central United States. And the Appalachian Mountains, they usually erode towards the east coast, and some of it down towards our direction through the Mississippi River. And so you have all these sediments that kind of combine in this area, this flat area with plains, and it creates sedimentary rock. There's no active plate tectonics in these areas, and so it's just kind of settling these rock layers one on top of another, and that forms sedimentary layers where sedimentary rock is found. And as the layers keep building up, you just get more and more sedimentary rock. So any place that you have a valley where erosion is taking all those sediments and it's depositing it down into those valley areas, that is where you're going to find sedimentary rock. Or if you have plains, right, or flat areas, such as here in Bartlett, then you have sedimentary rock. So if I were to dig right here in Bartlett, I would most likely find sedimentary rock. Now, saying all that doesn't mean that you can't find igneous and metamorphic rock in those areas. And I can find sedimentary rock in the Appalachian Mountains, and I can find igneous rock in the Appalachian Mountains, and same with the Rocky Mountains. I can find all three types of rocks, but it's more likely that I'm going to find igneous rock at the subduction zones. So that's like along the west coast where we see volcanoes and stuff, because there's the melting and cooling of magma that happens along those subduction zones. And so that's where I'm going to most likely find my igneous rock. Metamorphic rock I'm going to find it along mountain ranges where two continents have collided. and I can also find igneous rock in those, but mainly metamorphic rock. And then in the plains and in valleys is where I'm most likely to find sedimentary rock. In the next video, I'll show you a few examples of this, but I just wanted to kind of talk about plate tectonics and how they drive the rock cycle.